Welcome to the podcast. This week's episode, we're going to kick off a multi-part series with Kahn. Rez is a lead product manager here at MongoDB, and we're going to talk about automating database management. So what are some of the tools and what are some of the methods you can use to make the job of managing your databases much easier? This will be a multi-part series, like I said, and today's episode, we're going to focus on the index space, ensuring that your application is going to get the best possible performance, leveraging automated index suggestions. Stay tuned for the episode. I hope you enjoy it.
You're listening to the MongoDB Podcast.
MongoDB Podcast?
Exploring the world of software development, data, and all things MongoDB. And now your hosts, Michael Lynn and Nick Raboy.
Rez, thanks for taking time to be on this podcast episode. Before we get into the core material of actually talking about database management and the things that you can automate, let's take a step back and why don't you tell us a little bit about yourself?
Cool. Happy to be here, Nick. My name's Rez. I am a lead product manager at MongoDB. I work out of the New York office. And my team is roughly responsible for making sure that the experience of our customers are as amazing as possible after they deploy their first application on MongoDB, which means we work on problems such as how we monitor MongoDB, how we make sure our customers can diagnose issues and fix issues that may come up with MongoDB, and a whole host of other interesting areas which we can dive into throughout the podcast.
So when you're talking about the customer success after they've gotten started on MongoDB, are you referencing just Atlas, or are you referencing, say, Realm or some of the other tooling that MongoDB offers as well? You want to shed some light?
Yeah, that's a really good question. Obviously, the aspiration of the team is to help with all the products which MongoDB supports today and will eventually support in the future. But for the time being, our focus has been on how do we crush the Atlas experience and make it as magical of an experience as possible after a user deploys the first application.
How long have you been with MongoDB, and what were you doing prior to coming on board?
I've been with MongoDB for a couple of years now. Before joining MongoDB, I used to work in a completely different industry, advertising technology, and I spent 5 years at a New York startup called AppNexus, which eventually got sold to AT&T. And at AppNexus, I was a product manager as well. But instead of building databases or helping manage databases better, I built products to help our customers buy ads on the internet more effectively. And a lot of it was machine learning based products. So this would be systems to help optimize how you spend your advertising dollars. And the root of the problem we're trying to solve is figuring out which ads customers would click on and eventually purchase a product based out of, and how do we do that as effectively and as efficiently as possible. Prior to AppNexus, I actually spent a number of years in the research field, trying to invent new types of materials to build microchips. So it was even more off base compared to what I'm doing today. But it's always very interesting to see the relationship between research and product management. And eventually I found it was actually a very good background to have to be a good product manager.
Yeah, I would imagine you've got to be pretty curious to work in that space, looking for new materials for chips. That's pretty impressive. So you've been on board with MongoDB for 5 years, and did you go right into the Atlas space as a product manager?
So I've been with MongoDB for 2 years, and yes.
2 years. Sorry. Yeah.
No worries. I got hired as the third product manager for Atlas, and have been very lucky to work with Atlas when it was fairly small to what is arguably a very large part of MongoDB today.
Yeah. Yeah, it's huge. I mean, I remember when I started, Atlas didn't exist, and I remember when they made the first initial announcements, internal only, about this product that was going to be, in the cloud. I just couldn't picture it, and it's so funny to now see it it's become the biggest, I think, arguably the biggest part of our business. It's I remember watching the chart as it took more and more of a percentage of our gross revenue. And today it's a phenomenal story, and it's helping so many people. One of the biggest challenges I had even before coming on board at MongoDB was, how do you deploy this? How do you configure it? If you want high availability, it's got it. MongoDB has it built in. It's built right in. But you've got to configure it, and you've got to maintain it, and you've got to scale it, and all of those things can take hours and obviously effort associated with that. So to see something that's hit the stage and people have just loved it, it's just been such a success. So that's, I guess, a bit of congratulations on Atlas and the success that you've experienced. But I wonder if you might want to talk a little bit about the problem space that Atlas lives in. Maybe touch a little bit more on the elements of frustration that DBAs and developers face that Atlas can have an impact on.
Totally. Um, my experience with MongoDB is actually very similar to yours, Mike. I think I first used it at a hackathon back in 2012, and I remember, getting started with it was very easy. It took us 10 minutes, I think, to run the first query and get data from MongoDB. But once we had to deploy that app into production and manage MongoDB, things became a little bit more tricky. It did take us a number of hours to actually set things up, which is a lot in a hackathon because you get only 2 hours to build the whole thing, right? So I did not think too much about the problem that I experienced in my hackathon day when I was doing the hackathon till I came to MongoDB, and then I learned about Atlas, and I saw my manager deploy an Atlas cluster and show me an app, and the whole experience of having an app running on a production version of MongoDB within 20 minutes was absolutely magical. And digging deeper into it, what the problem we're trying to solve is this. We know that the experience of using MongoDB is great as a developer. It's very easy and fast to build applications. But once you want to deploy an application, there is a whole host of things you need to think about. You need to think about how do I configure the MongoDB instance to have multiple nodes so that if one of those nodes go down, you'll have a database available. How do I configure backup of my data so that there's a copy of my data always available in case there's a catastrophic data loss? How do I do things like monitor the performance of MongoDB, and if there's a performance degradation, get alerted that there's a performance degradation? And once I get alerted, what do I need to do to make sure that I can fix the problem? And if the way to fix the problem is I need to have a bigger machine running MongoDB, how do I upgrade a machine while making sure my database doesn't lose connectivity or go down? So those are all not easy problems to solve. And in large corporations, you have teams of DBAs who do that. In smaller startups, you don't have DBAs. You have software engineers who have to spend valuable time from their day to handle all these operational issues. And if you really think about it, these operational issues are not exactly value-added things to be working on, because you'd rather be spending the time, building differentiating features in your application. So the value which Atlas provided is we handle all these operational issues for you. It's literally a couple of clicks before you have a production instance of MongoDB running with backup, monitoring, alerting, all those magically set up for you. And if you need to upgrade MongoDB instances, or you need to go to a higher, more powerful instance, all those things are just one click as well, and it takes only a few minutes for it to be configured for you. So in other words, we're really putting a lot of time back into the hands of our customers so that they can focus on building, writing code which differentiates their business as opposed to spending time doing ops work.
Amazing. I mean, truly magical. So you talked quite a bit about the space there. You mentioned high availability. You mentioned monitoring. You mentioned initial deployment, you mentioned scalability. And, I know we talked before we kicked the podcast off. I'd love for this to be the introduction to database management automation, because there's just so much we could probably make 4 or 5 episodes alone. But Nick, did you have a question?
Yeah, I was just going to ask. So, of all the things that Atlas does for us, I was just going to ask: is there anything that still does require user intervention after they've deployed an Atlas cluster, or is it all automated? I mean, this is on the topic of automation, right?
Yeah, I mean, I wish everything was automated, but if it were, I would not have a job.
Yeah.
So there's obviously a lot of work to do. The particular area which is of great interest to me and the company is, once you deploy an application and the application is scaling or is being used by lots of users, and you're making changes to the application, how do we make sure that the performance of MongoDB itself is as awesome as possible? Now, that's a very difficult problem to solve, because you could talk about performance in a lot of different ways. Um, one of the more obvious proxies of performance is how much time it takes to get responses to a query back. And you obviously want it to be as low as possible. Now, the way to get a very low latency on your queries is you can have a very powerful machine backing that MongoDB instance. But the consequence of having a very powerful machine backing the MongoDB instance is it can be very costly. So how do you make sure costs are manageable while getting as great of a performance as possible is a very difficult problem to solve. And a lot of people get paid a lot of money to solve that particular problem. Um, so we have to characterize that problem first. So to kind of track the necessary metrics to measure cost, measure performance, and then we need to think about, how do I detect when things are going bad? And if things are going bad, like, what are the strategies I can put in place to solve those problems? Um, Luckily, with MongoDB, there's a lot of strategies you can put in place. You could, um, for example, one of the attributes of MongoDB is you could have, multiple secondary indexes, and those indexes can be as complex or as simple as you want. But when do you put indexes? What indexes do you put? When do you keep indexes around versus when do you get rid of it? And those are all decisions you need to make, because making indexes is something which is neither cheap, and keeping them is also not cheap. So you have to do an optimization in your head on when you make indexes, when you get rid of them. And those are the kind of problems that we believe our expertise in how MongoDB works, the performance data we're capturing from you using MongoDB, can help us provide you more data-driven recommendations, so you don't have to worry about making these calculations in your head yourself.
And the costs that you mentioned, there are costs associated with implementing and maintaining indexes, but there are also costs if you don't, right? If you're afraid to implement indexes because you feel like you may impact your performance negatively by having too many indexes. So just having the tool give you visibility into the effectiveness of your indexes and your index strategy, that's powerful as well.
So, what kind of visibility would you exactly get? I want to dig a little deeper into this. So, say I've got my cluster and I've got tons and tons of data, and quite a few indexes created. Will it tell me about indexes that maybe I haven't used in a month, for example, so that way I could remove them? How does it relay that information to you effectively?
Yeah, I mean, what the system would do is, it keeps a record of all indexes that you had made, and it will track how much you're using certain indexes. It will also track whether there are overlaps between those indexes, which might make one index redundant compared to the other. And then we do some heuristics in the background to uh, look at each indexes and make an evaluation, like whether it's possible or whether it's a good idea to remove that particular index based on how often it has been used over the past X number of weeks, whether there are overlaps with other indexes. And all those things you can do by yourself, but these are things you need to like learn about MongoDB behavior, which you can, but why do it if we can just tell you that this is something which is inefficient, and these are the things you need to like make to make your internet more efficient.
So I want to be cognizant that not all of the listeners of our podcast are going to be super familiar with even indexes, the concept of indexes. So can you maybe give us a brief introduction to what indexes are and why they're so important?
Yeah, that's a really good question. So in when you're working with a data, so indexes are not something which is unique to MongoDB. All other databases also have indexes. The way to look at index is it's a special data structure which stores the data you need in a manner that makes it very fast to get that data back. So one good example is, let's say you have a database with names and phone numbers, and you want to query the database with a name and get that person's phone number. Now, if you don't have an index, what the database software would do is it would go through every record of name and phone number till it finds the phone number, finds the name you're looking for, and then it will give you back the phone number for that particular name. Now, that's a very expensive process, because if you have a database with 50 million names and phone numbers, that would take a long time. But one of the things you can do with indexes, you can create an index of names, which would organize the data in a manner where it wouldn't have to go through all the names to find the relevant name that you care about. It can quickly go to that record and return back the phone number that you care about. So instead of going through 50 million rows, you might have to go through a few hundred rows of data in order to get the information that you want. And suddenly, your queries are significantly faster than what it would have been if you had not created an index. Now, the challenge for our users is, like you said, Mike, a lot of people might not know what an index is, but people generally know what an index is. The problem is, like, what is the best possible thing you could do for MongoDB? And there's some stuff you need to learn. There's some analysis you need to do, such as you need to look at the queries you're running to figure out which queries are the most important. And then for those queries, you need to figure out what the best index is. And again, you can think about those things by yourself if you want to, but there is some analytical, logical way of giving you, of crunching these numbers and just like telling you that this is the index, which is the best index for you at this given point in time. These are the reasons why, and this is the benefit you would give you.
So, okay, well, indexes sound like I need them because I've got an application and I'm looking up phone numbers, and I do have a lot of phone numbers. So I'm just going to index everything in my database. How's that sound?
I mean, it might be fine actually. It depends on how many indexes you create. Um, the, the thing which is tricky is, because indexes are a special data structure, it does take up storage space in the database, because you're storing in my example from before, like names in a particular way. So you're essentially copying the data that you already have, but storing it in a particular way. Now, that might be fine, but if you have a lot of these indexes, you have to create lots of copies of your data. So it does use up space, which could actually go to storing like new data. It also has another effect where if you're writing a lot of data into a database, every time you write a new record, you need to make sure all those indexes are updated. So writes can take longer because you have indexes now. So you need to like strike a happy balance between how many indexes do I need to get great read performance, but not have too many indexes so my write performance is hurt. And that's a balancing act that you need to do as a user. Or you can use our tools and we can do it for you.
There you go. Yeah, obviously playing a little devil's advocate there, but it is important to have the right balance, and
Absolutely.
you base the use of your index on the read-write profile of your application. So knowing as much about the read-write profile, how many reads versus how many writes, how big are each, is incredibly important. So so that's the space that this is in. And is there a tagline or a product within Atlas that you refer to when you're talking about this capability?
Yeah. So there's a product called Performance Advisor, which when you can use via the API or you can use via the UI. And when you use Performance Advisor, it will scan the queries that ran on your database and give you a ranked list of indexes that you should be building based on importance. And it will tell you why a particular index is important. So it would give you, we have this very silly name called the impact score. It would just tell you that this is the percentage impact of having this index built, and would rank index recommendations based on that. One of the really cool things we are building is, so we've had Performance Advisor for a few years, and it's a fairly popular product amongst our customers. Our customers who are building an application on MongoDB Atlas, or if they're changing an application, the first thing that they do after deploying is they would go to Performance Advisor and check to see if there are index recommendations. And if there are, then they would go and build it. And magically, like, the performance of their queries become better. And because we have had good success with the product, what we have decided next is, why do even make people go into Atlas and look at the recommendations, decide which they want to keep, and create the index manually? Why not just automate that for them? So when you deploy an Atlas cluster, you can say, I want indexes to be built automatically. And if you have it turned on, then we will be proactively analyzing your queries behind the scenes for you. And as soon as we detect queries which doesn't have an index and is important and causing performance degradation, we can automatically figure out like what that index ought to be, and then build that index for you behind the scenes in a manner that it's performant. And that's a product which we're calling Autopilot Mode for Indexing, which is coming in the next couple of months.
So I have a question around autopilot indexing. So you're saying that it's a feature you can enable to allow it to do it for you on a needed basis. So around that, will it also remove indexes for you that are not that are below the percent threshold, or can you actually even set the threshold on when an index would be created?
So I'll answer the first question, which is, can it delete indexes for you? Today it can't. So we're actually releasing another product within Performance Advisor called Index Removal Recommendations, where you can see recommendations of which indexes you need to remove. And the general product philosophy that we have in the company is we build recommendations first, and if the recommendations are good, then we can use those recommendations to automate things for our customers. So the plan is over the next 6 months to provide recommendations on when indexes ought to be removed. And if we get good user feedback and if it's actually useful, then we will incorporate that in Autopilot Mode for Indexing and have that system also delete indexes for you. Regarding your second question of, are the thresholds of when indexes are built configurable? That's a good question, because we did spend a lot of time thinking about whether we want to give users those thresholds. And it's a difficult question to answer, because on one hand, having knobs and dials and buttons is attractive because you can, as a user, you can control how the system behaves. On the other hand, if you don't know what you're doing, you could create a lot of problems for yourself. So, and we want to be cognizant of that. So what we have decided to do instead is we're not providing a lot of knobs and dials in the beginning for our users. We have selected some defaults on how the system behaves based on analysis that we have done on thousands of customers, and hoping that would be enough. But we have a window to add those knobs and dials back if there are special use cases for our users. But we will do it if it makes sense, obviously.
So, I mean, the reason why I asked is because you've got the category of developers who probably under index, right? And then to flip that switch, and now is there a risk of over indexing now in that sense?
That's a great question. The way we build the system, we built some fail safes into it where the risk of over indexing is very limited. So we do a couple of really cool things. One of the things we do is, when there is a index that when we detect that there's an index that we can build, we try to predict things such as how long an index would take to be built. And then based on that, we can make a decision whether we'll automatically build it or we'll give user the power to say yay or nay on building that index, because we're cognizant of how much time and resources that index build might take. We also have fail safes in the background to prevent runaway index build. I think we have this configurable threshold of, I forget the exact number, like 10 or 20 indexes per collections that can be auto built. And after that, it's up to the users to decide to build more things. The really cool part is, once we have the removal recommendations out, and assuming it works if it works well and users like it, we could use that as a signal to automatically remove indexes if you're building too many indexes. So it's like a very neat, closed loop system where we build indexes and observe how it works. If it does work well, we'll keep it. If it doesn't work well, we'll remove it. And you can be, as hands off as you want.
That sounds incredibly exciting. I think I have a lot of fear around that, though, especially because of the the speed at which a system like Atlas, with an application running against it, the speed to make those types of changes can be onerous, right? And to continually get feedback and then act on that feedback. I'm just curious, is that one of the challenges that you faced in implementing a system like this?
Yeah, I mean, one of the big challenges is, we talked about this a lot during the R&D phase, is we think there are two strategies for index creation. There is what we call reactive, and then there is proactive. Reactive generally is you make a change in your application, and you add a query which has no index, and it's a very expensive query. You want to make the index as soon as possible in order to protect the MongoDB instance from a performance problem. The question is, what is soon? How do you know that this particular query would be used for a long time versus just used once? Like, it could be a query made by an analyst and it's expensive, but it's only going to be used once, so it doesn't make sense to build an index for it. That's a very difficult problem to solve. So in the beginning, our approach has been, let's be conservative. Let's wait 6 hours and observe what a query does for 6 hours. And that gives us an adequate amount of confidence that this is a query which is actually going to be there for a while, and hence an index makes sense. Does that make sense, Mike?
Yeah, it does. Yeah, perfect sense. And I'm thinking about the increased flexibility associated with leveraging MongoDB in Atlas. Now, obviously, MongoDB is an open database. You can download it, install it on your laptop, and you can use it on servers in your data center. Will any of these automation features appear in the non-Atlas product set?
That's a really good question. We obviously want to make it available to as many of our customers as possible because it is very valuable to have systems like this. There are some practical realities that make it difficult. One of the reality is when you're using Atlas, the underlying machines, which is backing your database, is something that we can quickly configure and add very easily, because MongoDB is the one which is managing those machines for you, because it's a service that we provide. The infrastructure is hidden from you, which means that automation features where we need to change the underlying machines very quickly is only possible in Atlas because we control those machines. So a good example of that is, and we should talk about this at some point, we have auto scaling, where we can automatically scale a machine up or down in order to manage your load. We can't, even if you want to, we can't actually give that feature to our customers using MongoDB on premise because we don't have access to the machine, but in Atlas we do. For automatic indexing, it's a little bit easier because it's more of a software configuration. So it's easier for us to give it to other places where MongoDB is used, and we definitely want to do that. We're just starting with Atlas because it's faster and easier to do, and we have a lot of customers there, so it's a lot of customers to test and give us feedback about the product.
That's a great answer, and it helps me to kind of draw it out in my head in terms of an architecture. So it sounds like there's a layer above. MongoDB is a server process, and you connect to it to interface with and to manage your data. But in Atlas, there's an additional layer that is on top of the database, And through that layer, we have access to all of the statistics associated with how you're accessing your database.
Mhm.
So that layer does not exist in the downloadable MongoDB
It
today,
doesn't.
anyway. Right?
Yeah. It
Okay.
doesn't.
Yeah.
Exactly.
Wow. So that's quite a bit in the indexing space, but that's just one piece of the puzzle, right? Database folks that are leveraging the database are struggling across a whole bunch of areas. So what else can we talk about in the space where you're solving these problems?
Yeah, there is so much. Like you mentioned, indexing is just one strategy for performance optimization, but there's so many others. One of the very common or uncommon, whoever you might ask this, is what should the schema of your data be, and how do you optimize the schema for optimal performance? That's a very interesting problem space, and we have done a lot of thinking on that, and we have a couple of products to help you do that as well. Another problem is what how do we project out, how do we forecast what your future workload would be in order to make sure that we are provisioning the right amount of machine power behind your database so that you get the best performance but don't pay extra when because you're over provisioned. um, when is the best time to have a shard versus scale up vertically, and what is the best shard key to use? That is also another interesting problem space for us to tackle.
Mm-hmm.
So there's a lot to talk about, and we should at some point.
And these are all facets of the product that you manage.
These are all facets of the product that we manage. Yeah. One thing which I would love to invite our users who are listening to the podcast. Like I mentioned before, we're building this tool called Autopilot mode for indexing to automatically create indexes for you. It's in heavy engineering development right now, and we're hoping to release it in the next couple of months. And we're going to be doing an early access program for that particular product, trying to get around 100 users to use that product and get early access to it. And I would encourage you guys to think about that and give that a shot.
Who can participate? Who are you looking to get their hands on this?
In theory, it should be anyone. Anyone who is spending a lot of time building indexes would be perfect candidates for it. And all of our MongoDB users spend a lot of time building indexes. So we are open to any type of companies or use cases, and we're very excited to work with you to see how we can make the product successful for it and use your feedback to build the next version of the product.
Great. Well, this has been a phenomenal introduction to database automation, Rez. I want to thank you for taking the time to talk with us. Nick, before we close out, any other questions or things you think we should cover?
No, not for this episode. And then, if anyone has any questions after listening to this episode, please jump into our community. So this is a community forum board. Rez, Mike, myself, we're all active in it. It's community.mongodb.com. It's a great way to get your questions answered about automation.
Absolutely. And Rez, you're in there as well. You taking a look at some of the questions that come across from users?
Yeah, I do that occasionally. Not as much as I should, awesome. But I do that.
Awesome.
Well, if there's a question that pops up, we'll pull you in.
Yeah, if we get some more questions in there, we'll get you in there.
Sounds good.
Awesome. Well, terrific, Rez. Thanks once again for taking the time to talk with us. And I'm going to hold you to that. We're going to take this in a series approach, and we're going to break all of these facets of database automation down, and we're going to cover them one by one. Today's been an introduction and a little bit about autopilot mode for indexing. Next one, what do you think? What do you think you want to cover next?
Let's do scaling.
Love it.
Scaling and auto scalability. I love it. Awesome. All right, folks. Thanks.
Thank you.
Thanks for listening. If you enjoyed this episode, please like and subscribe. Have a question or a suggestion for the show? Visit us in the MongoDB community forums at community.mongodb.com.